Great, so we want to learn some formulas for differentiation. It turns out that when you take a derivative, this whole thing about f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. It turns out that we don't have to do that all the time. It turns out there's another way. So let's identify some really, really basic derivatives that we can accomplish. For example, suppose that f of x is equal to a constant, say f of x is equal to 5. What kind of line is f of x equals 5? Don't say straight line, all lines are straight. Horizontal line. What is the slope of a horizontal line?
0.
So therefore, the derivative of a constant is equal to 0. Because derivatives are slope. Everybody okay there? Okay, then we have f of x is equal to x. What kind of a line is that? Don't say straight.
Vertical.
Good try. Incorrect.
This way.
It's a this way line with a slope of 1. So therefore, the derivative is 1. Suppose you have a constant in front. Suppose it's f of x is equal to 9x. What's the slope of 9x? 9. So therefore the derivative is 9. Right? And then we get to this thing. All of a sudden, it's like, well, those were easy, Mr. Gans, because that is a constant and those have slope. And so... But when you increase the degree, well, that's where things kind of fall apart on us. That's where it gets rather difficult. So what we want to do is we want to look at what if you have x to the nth power. For example, problem number 4 was f of x is equal to x to the 5th power, and you had to multiply out x plus h 5 times, right? Well, that takes a while, doesn't it? Okay. So let's use our intelligence that we have about calculus to come up with something cool. We have the limit as h goes to 0 of, so I'm going to use x to the nth. What do we plug in for x? X plus h, and we raise it to what power? Nth power. Minus x to the nth all over h. Okay, so that's what we're trying to figure out. That will be the derivative of a polynomial. Okay, so what do we do? Limit as h goes to 0, x plus h to the nth. That looks really complicated. Do you agree? Like that, multiplying that out n times, I don't really know what that would look like, but I do know like the first part, right? What would the first part be? X to the nth power. Right? What would the last part be? And then we would have minus x to the nth. And that would be all over h. Great. So now we just got to figure out the middle, right? Do you remember last year? Don't say no right away. Do you remember last year when we did the binomial theorem? I'm like, okay, Mr. Jens, I don't know names like that. Could you be a little bit more descriptive? Sure, I will. Do you remember when we did this? A plus b to the 6th power. And we set up something referred to as Pascal's triangle. Anybody remember the next ones?
No.
1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, then 1, 6, I always start with 1, 15, 20, 15, 6, and 1. Yeah. So it turned out that if we want to raise that to the 6th power, it's really not that bad at all. All we have is we have a to the 6th, okay? and then we have a to the fifth, and we pick up a b, and then we have an a to the fourth, and we pick up a b squared. We have an a to the third and a b to the third. Then we have an a squared and a b to the fourth. Then we have an a and a b to the fifth, and we have a b to the sixth. And it turns out that these are the coefficients, aren't they? So like, what's always the coefficient for this? 1, and it turns out the coefficient here is the same as the exponent there. See that? Turns out that whatever power you're taking to, that's what ends up being there. Look at this row right here. 1, 2, 3, 4, 5, 6. See that? That's kind of handy, isn't it? And then we would have like 15, and we would have 20, and we'd have 15, and we'd have 10, or I'm sorry, 6. And then we got this 1 over there, okay? And all of a sudden we expand it out. We didn't have to multiply it out 6 times, did we? So now that you've seen that, watch how nicely this works out here, okay? I have an x to the nth. My next term will be x to the, what will happen to the power? It will reduce by 1, so it'll be an n minus 1. And what will I pick up? An h. Okay? And then I will have an x to the n minus 2, and I'll pick up an h squared. Okay? So on and so forth. Let's talk about the coefficients out front. What's going to be the coefficient in front of this guy? N, right? Whatever the power is, that's that coefficient, isn't it? After that, we really don't know what the coefficients are. We'll just put a C there for coefficient. It doesn't matter in the process anyway. That's the toughest part. Now it all becomes super easy. You're going to love it. What happens?
X to the nth power cancels.
X to the nth cancels with x to the nth. Everything that's left has an h. So what can you do? You can divide an h out, right? And when you do, you get n times x to the n minus 1. What happens to this h? It's gone, and then that 1 reduces to 1. So you have a constant times x to the n minus 2 times h plus dot, 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 h to the n minus 1. Look at what you have left. Everything that's left, except for the first term, has what? Everything else has an h, right? It's only this first one that doesn't, right? So what happens when you plug in 0? Everything that has an h is all just going to vanish, is it not? And so you are only left with that thing. What does that mean? It is very simple. If f of x is equal to x to the 6th, we don't have to use x plus h. What do we do? The derivative is very simple. All we do is we take the power and we drop it in front to get 6, and then what do we do the exponent? We subtract 1.
Which is exactly how you
That's the derivative.
Whoa.
Watch, you'll be able to try it yourself. I mean, it's super cool how it works out so quickly and so easily. Let's see. I'm going to put one up here. You have x to the 8th. Let's see if you can come up with the derivative. If that's the function, come up with the derivative. Come on, grab the pen. Come on, put it on up here, Lily. See if you can grab that derivative, put it on the board. If f prime of x, we got 8x to the, give her a round of applause. All right, look at you. Can you imagine how long that would take us if we plugged in an x plus h? Oh my goodness. Let's try another one. Who wants to try this one?
Hannah does.
Hannah! Give it up for Hannah, everybody! Woo! Come on up, Hannah. We're going to do a tough one this time. We're going to do x to the 19th. Whoa! That's tough. Let's see what she can
board
do.
is really
X,
bright.
stop it. Stop. It's a nice board. X to the 19th. Can she do it?
Wrong.
Hannah, that's the biggest I've ever seen. And you did it wrong.
Yeah, good. You got it.
Hold on. Oh, here we go. Here we go. No.
She got it! Yeah! Who's ready for a challenge?
Taylor is.
Come on. Who wants to try a tougher one? Come on. Get Matthew. Come on up. Give it up for Matthew. Here we go, Matthew. All right, let's go, Matthew. This is probably impossible. I don't think I've ever had somebody do this problem before. X to the 1000th power. Let's see. And he got it, all right. Hey, watch this. Suppose I had f of x is equal to x to the pi power. That looks ridiculous, doesn't it? Well, derivative, no problem. We just drop the pi in front, and we just then take pi minus 1. Like, you're done. Like, that's it. That's all there is to it. In fact, suppose you changed it, and you had f of x is equal to 4x cubed minus 13x squared plus 2x minus 8. Now all of a sudden I have a polynomial. Can everybody agree that if you were to take that derivative using x plus h, that would take a long time? Well, watch. We just drop this and multiply in front. It becomes what? 12 times x to what power? Squared minus 26 to the x plus, what's the slope of 2x minus 8? 2. That's your derivative. That's it. That's all we have to do. And thus it is time to celebrate this wonderful, wonderful moment where we are able to take our derivatives. It is time to transition into our, what do you want to call it?